Hey everyone, welcome to another video. Yesterday, I think I posted a video which I have made private, and basically in that video, I was ranting about how cumbersome the pipelines are for animal behavior analysis, especially for people who are from background that is non-technical or non-computer science. So by that, what I mean is that you have to do your key point tracking first, then you have to set up often like this kind of a pipeline where you have to train another neural network to segment behavior and then ultimately get to quantification of behavior. And it gives you these groupings, right? So BSOID and VAME or VAME, these are very popular tools for understanding different types of behaviors. They're very good for exploratory behavior analysis. But traditionally, what I have used for quantitative behavior analysis are either visual markers of a behavior happening or with just basic threshold segmentation and tracking behavior like that. So especially with single animals, oftentimes we will see an open field where the behavior such as rear or supported rear, which is that the mouse goes up against the wall and that's a supported rear. So these have established pathophysiological links, especially with schizophrenia studies. And anyways, the point is that certain behaviors don't really you don't need to go through all of these extra cumbersome pipelines. And at some point, I think these pipelines will become easier to use. But for many research questions where you don't need neural networks for identification of behaviors, there can be some way to integrate key point, the key point pose estimation type of a pipeline with clearly distinguishable, visually discernible behaviors. And so in the video that I have made private, I was ranting about those things, and then somebody close to me pointed out that instead of talking about how these tracking tools can integrate a layer for behavior, instead of talking about it, why don't you show people what you mean? So in this video, I'm going to give a very quick demo of that, and then I would love for community to provide feedback on it. So this video is not necessarily a tutorial, but rather a question. Would it be helpful to integrate with key point tracking, which means the pose estimation stuff like deep lab cut and sleep? Would it be beneficial for certain questions to have the ability to track broad behaviors such as grooming, wall rearing, exploration, general walking, those type of things built into the initial model that you are training for key point estimations? And that's the question, right? So for certain research queries and questions, one does not need to do extra behavior segmentation, because that's not the goal, right? It's for some researchers, it's not the goal to identify some novel behavior or how behaviors are happening or what trajectory a limb is moving in versus another limb, right? So for certain questions that are broad, phenotype based, but there are certain things that would be advantageous to have a model that does both pose estimation simultaneously as a behavior. Okay, so I'm going to show what I have and take it with a grain of salt, but this is going to play out in real time. I've just started that pipeline over here. Let's see what you guys think of it. I know it's going really fast, but you can see the key points are being tracked on the mouse, as well as the behavior that is happening. Okay, so I'm going to stop it right here, and then the video that is being saved in the background, we can look at this, and this will go in slow motion. Okay, so here the key points are being tracked on the mouse. The behavior that is being observed is also labeled, right? So it's happening all in one model. That one model is doing both of these things simultaneously. So here, when the model is not very well trained, and of course I'm not a software engineer, so it is missing out on certain behaviors like you see right here. So I only trained it for classifying two behaviors. One is a general term, right, for everything that is not a wall rear. It's classifying everything else as a general behavior, general category. And when the mouse is doing this kind of a wall rear, which is very, very easy to differentiate from all kinds of other behaviors, it's clearly labeling it with high confidence as a wall rear. So here it's missing that part. So, right, this can be overcome with training data. And of course, you can see the key point tracking is not really that good. But again, this is all fixable with good quality video, with more data for training and those type of things. But the point here is to demonstrate that it's doable. Uh, it, it's absolutely doable that a single model can do both key point tracking for different body parts, and also to give us a overall behavior based off of the posture of the animal in the video frame. Okay, so for some questions, some research questions that only need a behavior based off of posture, for example, a mouse might be in an aggressive posture, right? And that our eyes can clearly distinguish that, our brain can figure that out, but we can also train a model to identify those type of nuanced postures, right? And the other thing is, like, for things that happen in an open field, ethologically relevant behaviors don't often require kinematic analysis, or at least from my naive perspective, they don't. But kinematics is good to have because you can figure out some novel behaviors if that is the research goal. But I thought, why not have a single model that can do both? And that's the demo. So I'm going to stop ranting about this. The other video that I was ranting about the same concept, I've made that video private. I'm going to leave this one up. Please feel free to give me more feedback. If you think this will be a beneficial addition, I can maybe make a video about how to do this, and you guys can try this out on your own. So thank you so much for paying attention, and I appreciate the feedback that the community provides me. And I'm here to learn and grow, and I hope you guys are here for the same thing. Thank you so much. Bye-bye.